Okay, so we will give a very quick introduction to how to use Fluka. We'll connect to one of the computers at UB using AnyDesk and try to set up a very simple example. So I choose the folder I want to store my project, and I can select Open in Terminal. And to open Fluka with the graphical user interface, I write Flare. Okay, let's see. So this is Flare. We want to start a new project. So we can choose New. And there is different templates here. We'll just use Basic for this example. And then it says a new input file has been created. So here we have different tabs. So to look at the input file where we will define our simulation, we can choose this input tab. Okay, so in Fluka there are many different settings we can work with, but in this example we'll just make it very simple. So if we go to this part here, it's called the beam card. We can select the type of particle we want to simulate, and here I can just start typing, and I find proton, and we want to define the beam energy instead of the momentum. All the units here are in GeV, so if I want to have 100 MeV, for example, it will be 0.1. Okay, so we'll move to the next so-called card, beam position, and by default the beam starts in origo. I can move the beam to, let's say, -1, and here it says it's moving in the positive direction, and by default it moves along the Z axis. We can have a look in the geometry tab. So right now we will have a proton beam which will start at Z equals -1, and you see here is the Z axis. So it will start here and it will go this way. So it will hit the target. Right now our target is a cylinder. You can see it by in this other view here that it's circular here. But I just want to change it to a simple box. So I take this target and I select change, geometry, bodies, RPP. And then the position or the size. Say we go from in 10 centimeters from -5 to 5, -5 to 5, and from 0 to 10. Here you can write comments. Target. And then I want to change this from copper to water. Okay, let's have a look again. Now it's blue because it's defined as water, and you can see that it's now rectangular. Okay. So then we have our beam, and we have our target. Outside the target now we just have vacuum. And now we want to add some scoring. So scoring is when we record, for example, dose. So here you can right click, add, user bin, and here we just choose one of these, output none. numbers. For example, 22. Type XYZ, which is the most common. Then we can write in the region we want to look at the dose. And then we also have the resolution. So if I write 10 here, we will have 10 bins or one dose value per centimeter. 10. And if we want, we can have more in the depth direction to see a bit more details. For example, 40. Then what do we want to score? Dose. Okay. Now press save here. Just call it example 1. Then I will press primary, and we have to decide how many protons we will simulate. Let's take 10,000. And then instead of, now it's set up to run the simulation 5 times, but instead I will take it down to 1, and then I will write 5 here, which means that we will distribute it over 5 different CPUs, which is what we normally do. So I'll just try to run it and see if it works. To see the progress, we have to choose one of these. We can see that it's already running, and quite soon we'll be finished. Okay, so all the 5 simulations are finished. We can go to Files. Here you will see that you get an output file and some other files as well. The output file has lots of info, and if you have errors, they will often show up here. Here it actually says that there's an error, but I'm not quite sure. It's a real error. Let's see. Let's look at the results first. So here we have 5 scoring files. By pressing process, we will merge these into one. And it says it's done. We can then go to plot, and I can simply press this button here to generate a default plot. So now it says 2D plot, and when its set is chosen, it will plot Y and X, but I will change it to Y, so we will see Z and the X. So let's just try. Okay, looks okay. It's not so easy to see here, but the beam is coming in from the left, and then we have the brag peak here and some lateral dose. Let's instead plot in 1 dimension along Z. Yes, here we see the brag peak. To get it more visible, we can perhaps choose a different style. For example, this one. We'll see it. So that's it, a very simple Fluka simulation.